Hey students, I wanted to go over problem number 1 from the book in section 4-2. What are we doing here? We're stacking all these rectangles up. We're trying to make a pattern out of it, okay? We're trying to describe the pattern it makes. Kind of already cheated here a little bit. I've worked ahead. When we have one rectangle, we have a perimeter of 14. When we have two rectangles, we have a perimeter of 16, 3, 18, 4, 20. Where these numbers come from, I counted around the outside and added some extra numbers so we can see stuff here. Now, I've also written down the pattern. As the rectangles increase by 1, the perimeter increases by 2. So there's your story right there. Because what we're trying to do is we're trying to describe this in a table, in words, in an equation, and a graph. Well, there's your table right there. All I'm doing is I'm organizing the information to a nice, pretty table. From there, you can start looking for patterns. Looks like every single time I added a rectangle, I added 2 more units to my perimeter. So that's basically my story that I'm going to say right there. As the perimeter increases by 2, the perimeter increases by 2 every single time I add a rectangle. There you go. There's the story. They get a bit more detail, and I'll try to explain their reasoning as well. They say you multiply the number of rectangles in each figure by 2 to get the top and the bottom. That's why you have 2. Every single rectangle has 1 on the top and 1 on the bottoms. That's why they take it times 2. And then they add 12. Well, where does that 12 come from? Well, no matter how many rectangles you add, you're always going to have the 6 on the left and the 6 on the right. 12. 6 on the left, 6 on the right, 12. 6, 6, 12, 6, 6, 12. That's where the 12 comes from. Now, that's kind of the extra number when you start making equations. So here's their answer for the equation. So that times 2 is going to show up. It shows up right there, and it shows up right there in the story, and it also shows up again right there in the equation. Now, where in the world does that 12 come from? Well, this is known as a constant. This 12 was always in there. That 12 is constantly in the situation. No matter how many rectangles we have, we're always going to have that 6 on the left and 6 on the right. That's called the constant. How do you find the constant really quick looking at a table? I don't see the number 12 in here. You're right, it's not in there. Here's what you do. You backtrack a little bit. If you ever have 0, okay, in your independent variables, the other number will always be your constant. Where did this come from? I just backtracked. So if it's plus 2 this way and I backtrack 1, I'm going to backtrack 2 and get 12. So right there is my constant. We'll give this another name, excuse me if I can spell. We'll give this another name in future lessons, all right? So look at this, 2, 12, right there in my table, okay? 2, 12, right there in the story. 2 and 12, right there in my equation. Now the graph is actually really easy to make. You just plot the quarter points, all right? The table and the graph are basically lined up. You just take those and make quarter points out of them. So there's 1 and 14. They kind of decided to really space this out really goofily. Like there's 1 and 14, there's 2 and 16, there's 3 and 18, and there's 4 and 20. Now, what about that 0 and 12? Okay, well, it would be here in a graph, but in real life, you really can't have a 0 pattern. Where is the 0 pattern for this? I don't know. There really is no 0 pattern, but mathematically, that's the only way we use 0 to get that 12, that constant. So the 12 really doesn't show up in the graph, but the 2 and the 12 show up in the equation, in the words, and in the table. So let's move on to the other example that they give us here. Here's the guided question. So here's your notes right here. So this is what you should do on your notes. Okay, this is for you guys. All right, here we go. Basically the same idea. We've got now a pattern of triangles, all right? So in a table and in words, an equation, and a graph, map this all out. Okay, so here's my table. So I'm going to go triangles right here, perimeter right here, 1 triangle, 2 triangle. Sorry about that, got interrupted by the bell. Okay, so 1 triangle, there's a perimeter of, it looks like 10. All right, and then the second triangle, let's see here, 7 and 7 is going to make 14. Kind of already see my pattern going on here. I add a third triangle, I'm going to have 18. And then I add a 4th triangle, I'm going to get 22. All right, so right away I'm going to start looking for some patterns here to describe the situation. It looks like it's increasing by 4. Every time I add a triangle, every time I add 1 triangle, add me 4 more for a perimeter. There's my story. So my words to describe it to somebody, I'm going to say for each triangle, add 4 to the perimeter. Just going to do some shorthand right there. So for each triangle, every time you add a triangle, you're going to add 4 to the perimeter. There you go. What's my equation? Good question. So the number 4 shows up. Repeated addition makes actually multiplication. Okay, add 4 over and over, add 4 over and over. That's actually going to be multiplication. My perimeter is going to be 4 times the number of triangles, and there's going to be some type of extra. Remember that constant? Well, what showed up every single time in this pattern? Okay, what was constant all the way through? The 3 on this side, the 3 on that side, this 3 and this 3, this 3 and this 3, this 3 and this 3. I think every single time we added 6. Okay, so I'm going to make this for the equation. So add 6. So 4 times the number of triangles plus 6. Where does that 6 show up in the table? Backtrack. If you're going plus 4 this way and plus 1 this way, backtrack. 0, 6. There it is again. All right, so backtrack to find that special number. So 6 and 4. 4 is right there. So in words, you can also say add 6 for each triangle, add 4 to the perimeter. I guess you could also say start at 6. Okay. Sorry, I got interrupted again. All right, the graph. These are really easy to make. Oh, by the way, students, when you're making tables, you always want to have your inputs right here, outputs right there. When it comes to a graph, you always want to have your inputs right here, outputs right there. All right. So we're going to have a number of triangles right here. We're going to have perimeter right here. Let's see here. When I had 1, 2, 3, 4. When I had 1, doing this all by hand here. When I had 1 triangle, I had 10. I'm just kind of making these numbers up, spacing them out as I see fit. 14, 18, 22. And these don't need to be perfectly accurate because we are sketching, but hopefully they form somewhat of a straight line. After all, we are doing linear relationships. Okay, there we go. That is the Got It question.